Hi, I'm Sangeeta Brahma. I'm from SECR, Bachelor of Computer Science and Networking and Computer Science. So for this lab 2, we're going to observe flags, offset, and erase values in assembly language. I'm using Visual Studio 2019. So let's jump into question number 1. So for question number 1, we're going to observe flag values such as overflow, sign flag, zero flag, auxiliary flag, and carry flags values when I execute each instructions. So let's jump into first instruction. When I press the F10, we can see there is some changes happen to the EX value. We can see the EX change to 10, and there is no any changes in the flags value. So it remains same as the initial value. And move on to the second instruction where we're going to add 2 to the AX. So we can see the AX now change from 10 to 12 and some changes in the flags too. So we can see the zero flag remains 0 because the result is 0, and then the pair, the sign flag, is also 0 because the result is positive. The third instruction where we're going to subtract 15 from the AX. So when I execute the third instruction, we can see the AX changes to negative values. So there are some changes in the flags value, such as we can see the PL, the sign flag, changes to 1 because the result is negative, and then the CY, the carry flag, is also 1 because there's some borrow happens during the subtraction. Fourth instruction where we're going to add 112 to the AX, and then we can see the EX change to positive, and then the sign flag value is also becomes 0 because the result is positive. Now let's move to the fifth instruction where we're going to declare AX as negative, and we can see the AX is also already is a negative value here, and then the PL also changed. The sign flag is also changed to 1 because the result is negative, and carry flag is also changed to 1 because the original value is not 0. The sixth instruction where we're going to move to the BH. So we're going to move 66 to the BH, and we can see changes in the BX, and then the flags remains same because the move instruction only copies the data to the register, so there is no any changes to have been made. And then the seventh instruction, we're going to increase the BX, and then when I execute the instruction, we can see the BX increased by 1, and the result also changes. Some flags may change depending on the value in the BX. And then the seventh instruction is multiply the age. And when I execute this one, the result is stored in AX, and then the overflow and carry flag can change depends on the multiplication result. So the last instruction is we're going to subtract, and then we can see AL is decreased by 3. The flags also change according to the final result shown in the Windows register. So for question 2a, we are going to observe the value of AL and also the value of overflag OV. So let's begin with question 2a. So for question 2a, I am going to put 80 hexadecimal to the AL. Next, I'm going to add 92 hexadecimal to the AL. Once I execute the second instruction, you can see the EAX change to 12 hexadecimal, and the OV becomes 1 because the addition produces a value outside the valid range for an 8-bit sign number. So therefore an overflow occurs. So the answer for question 2a is AL equals to 12 hexadecimal and OF equals to 1. Okay, let's move on to question 2b. So this time we are going to move -2 to the AL, and we can see the EX already negative value. Now we're going to add under 27 to the AL. So from the EX result, we can see the EX is already in positive value, and the AL is equal to 70, and then the OV is 0.
Good day everyone, my name is Sharvin. So, for this video presentation, I will explain the array bits that found in the question 3, that's one from Donkey, Fiona and Shrek. So the first, for the donkey, there's 3 items. The 3 items are 45, 45H, and then 4AH. So here we can see the EX for the 45, 45H, and 4AH. And then now we go to the Fiona. So the Fiona have 5 items: 45, 45H, 444H, 4A4BH, and 44AH. So Here we can see the array word types based on the Fiona. This is the Fiona for 45. For the Shrek, double words types are there. So, and the 5 items are initialized to 0. So we can see this from here for the Shrek. Is initialized to 0. For the 5 items are initialized to 0. So this video is presenting that we can see define the following arrays for the question 3 for Donkey, Fiona and Shrek. So next we move on to question number 4. Okay, this is the question 4 for the program that we do for the question 3. So now we define the value of the register that we do at the program at the question 3. So first, the MOV AL donkey, the register value for AL is 2DH. Following to for the 2, donkey 2 plus AL is equals to 4AH. For C, AX Fiona, the value of AX 002DH. For Fiona plus 2, 0045H. For Fiona plus 4, 044H. For the EX track, the track item, all the 5 items are initialized to 0. So the EX value is 0000000H. For the AH Fiona plus 8, the value of AH is 0 for H. For the last, the EAX value for 0, 0000000H, which is same as to the Shrek. For the AX Fiona plus 2, the value of AX is 000000045H, and then the Shrek EAX, the Shrek value becomes 0000045H. This is the video presentation for the question 3 and then 4. Thank you so much for watching.